So another very important topic, wide area network. What is wide area network and why do we need it? Why do we use it? And how we can use it? Just like a LAN. In a LAN, we have one network. Let's say this is a switch. It is connected with the multiple devices. If they want to communicate the other end, we have another switch. For example, this want to send information to this computer, it will go through a locally, which is also known as a LAN. But what in case this portion belongs to USA and this portion belongs to Australia? The same way this person wants to send the information to this person here, but this time we located on a different geographical location. To solve this issue, we use WAN, wide area network. And when we talk about wide area network, it means we must have kind of intermediary device or the service provider, which is ISPs, involved. So without ISP, we cannot do the communication between these two geographical areas. So WAN can support many different WAN protocols. When we talk about the WAN, they have different kind of the protocols. Just like we have Ethernet, okay. In under WAN we have PPP, we have HDLC, we have frame relay. Okay, now these days we have MPLS. So these technologies are the part of WAN. So as you can see, WAN can support many different WAN protocols that can help you extend your LAN to other LANs at remote site, connecting company sites together so information can be exchanged. Service providers allow you to lease or share connection that they already have installed. So service provider has, because this is service provider's headache to give you the connectivity between your this head office, your headquarter, to your branch offices. So in between, this is the service provider sitting. So as I mentioned, the most important protocol that is being used in a WAN is HDLC, PPP, frame relay, and ISDN. So as I have already mentioned, why do we need WAN? Basically, when we have this headquarter here, we have some mobile users, we have some telecommuters, we have branch office, we have another telecommuters, and they want to pass information between each other. So that is where we use the WAN. So WAN connects devices located in a different geographical regions. WAN utilized carries such cable companies to communicate across a different geography. So basically these will be the cable companies that will connect this piece with this one, this one with this one, this one with this one. Okay, so WAN utilize various type of serial connections, typically lower bandwidth than LAN, and we know from our experience LAN works at what bandwidth? Initially it was 10, then we have 100, then we have 1000, Now we have more than 1010 gig as well. Okay, but opposed to LAN we have WAN, which is typically a very slower bandwidth. Like if we talk about T1 line, which basically works at 1.454 Mbps, megabits per second only. Okay, so the basic idea is the connectivity, means we are not going to send like a bulk information using T1 lines. We will have some kind of relatively very light applications that will be working. Like for example, this mobile user, if want to access this headquarter, he or she will be using a very lightweight applications to access this the resources of these headquarters. Then we have multiple encapsulations, or the terms being used in a WAN. So first thing, in OSI layer, where this WAN falls, as you can see, this is pretty much on data link layer. Frame relay, PPP, HDLC, ATM, these all encapsulation or the protocols works at data link layer. So this is very important part. If I'm talking about uh, in perspective of the questions and answers of the interviews, so they could ask at what layer the PPP or HDLC work, or they even can be more specific, like they can say where WAN protocol being used. So you can answer the data link layer. And what will be at the physical layers, basically the serial connections. So we have multiple solutions that comes under WAN. We have leased lines, we have packet switching, we have circuit switching, metro ethernet, broadband. And what are those things? In leased line, as you can see, when you see a symbol like this, it is a serial link. When you see a straight line, it is ethernet. So this is serial link, serial connections, and the leased line is dedicated connection. As you can see, this is point to point. We have one router here, we have one router here, and this router belong to ISP. Now ISP has responsibility how they will reach the other connection, but this is how they're gonna give you a direct link to their routers, basically, with the running of what, either PPP or HDLC as a protocol. So what kind of uh, the speed you are going to get, it is T1, which I mentioned, like 1.54 Mbps when you are using leased lines. Then we have circuit switching. I will talk about packet switching later on. Circuit switching, these are very old technologies. I think you people are not as much older as I am. I do remember when we were using these modem or dial-up connections. Basically, those are connected directly to the PBX, or also known as POTS, plain old telephone systems. Okay, so we have kind of connectivity that basically going directly to the service provider with the help of these pods, and we are connected with that, and we have this predefined link there, predefined connection there. Okay, opposed to circuit switching, and in what technologies we use, like dial-up or the modems, if you are familiar with these things. Under packet switching, and we know when we talked about the routing, what happens in the packet switching. I told you in a circuit switching, this is a predefined path. They cannot take another path. But in a packet switching, we could have multiple paths. We have source here, we have destination here. For example, if source want to send information to this destination, the possibility is maybe it could choose this path. Maybe next time when it will come, it will choose this path. So it has, a variety. So that is known as a packet switching. But when we talk about the WAN packet switching, basically we are talking about the technologies like the frame relays or ATM or X25. In leased line, as you can see, we have point-to-point connection, only two links. But what in case if we have one headquarter which needs to connect with the multiple branches, branch 1, branch 2, branch 3. Okay, so in this fashion, if you are gonna do a lease line like this one here, this one here, this one here, it is gonna cost you so much. So that is where we are gonna use packet switching, which is relevantly much cheaper than the lease line. So in that case, what will happen, we have hub and spokes. These are known as spokes. Okay, then we have service provider that will connect our hub router with these spokes. Okay, if hub wants to communicate with this spoke, it will be like direct communication. But the drawback is that if this spokes wants to communicate with this spoke, means if somebody want to send information to this spoke here, it will always go through hub and then it will come back. So this is a single point of failure. For example, if this hub is down, everything is down. We do not have any kind of reachability. Okay, then we have metro ethernet. I'm not gonna go a lot in detail. As you can see, this is straight line cable. Basically they're using kind of layer 2 basically kind of functionality to connect these two branches basically. And then we have a broadband. Broadband is very similar to just like this point to point, but instead of, as you can see, they are using serial connection here, but they are connecting with service provider using DSL modem but Ethernet. So it is some kind of like they want to send information to serial link but with the help of Ethernet, which is known as PPOE, point to point over Ethernet. So this is point to point connection. They want to send information over serial connection but with the help of Ethernet. So if you are familiar with the broadband connections and if you go inside this broadband router, you will find this PPOE and they will provide you kind of username and the password. You need to provide that for the authentication purpose. So let's move further. Typical WAN terms. These are very important vocabularies. Basically as a professional you can use it, or when you are working in a production environment you can use, or even in a interview question they will be questioned as well. Like WAN, we know what WAN is. Then demarc, and you might be familiar with what demarcation point. So whatever, this is your customer side and this is your service provider. So whatever in between, like the boundary that start from customer or the service provider is called known as the demarcation point. The boundary between the customer in-house wiring and the service provider wiring is known as a demarcation point. Then we have CPE, customer premises equipment. So whatever the device is configured at the customer side is known as customer premise equipment. Then we have a local loop and CO that has to do with the service provider end. So local loop is, as you can see, this thing is known as local loop, the wiring running from the demarc to the central office. This is your central office. So whatever the wiring in between demarc and central office is known as local loop. And central office, the point where the local loop gains access to the service provider high speed trunk links lines. This is often referred as a POP or point of presence. So these are the things as central office or the difference between the CPE or CO. So what are the pieces? Because we just whatever discussed in earlier slides, we talked about like the logically, but we want to see how they physically are connecting with each other. So here's the diagram. Let's say we have one USA office and one is a Europe office. Okay, these are the CPEs, customer equipment, and these are the WAN connections, the service provider basically. We have one CSU, DSU device. This is just like the modem, basically doing the modulation or demodulation, whatever it is receiving from here is converting to WAN. And as you can see, this is the serial link, and this CSU is connected with a serial link with this router, and this router is then connecting with these things, and then similarly here as well. But if you want to see it piece by piece, this is how it will be look like. This is a demarcation point, and behind that we have a service provider, ISP. And from here we CPE starts our customer. Okay, and this is like RJ45 cable, which will be connected with the RJ45 of this CSU DSU device. And I told you what is it. It is basically doing the segregation between our service provider and our LAN environment. Okay, doing modulation, demodulation kind of, if you will. So let's move further. As I mentioned that this RJ45 cable will be connected here. Then this is known as DTE to DCE cable, or also known as V.3.5 V.3.5 cable. Basically provide the clocking or kind of information, you know. So one part of this thing will be connected here. Okay, and this another part which is a serial connection, will be connected here. So this is how your CPE customer equipments basically will be connected. But let me be very honest, this is very old technology and it has been obsolete, and it is replaced with what? With this thing, which is known as CSU-DSU module WIC 1DSU/T1. Just like this is the WIC card, this is the WIC 2T card. Okay, but it has, if you just zoom in, you will see it has a serial ports. Opposed to that, we have this RJ45 kind of WAN connectors. So what will happen, instead of going through this CSU DSU and then V.35 cable connecting here and there, you will run directly this cable all the way to this module, which will be connected in the router by default. Okay, so this is how your WAN connectivity will be done at your on your premises. So since I was talking about that V.35 DTEDC cable, so I thought that I should add more knowledge and information about that, because this is a very good interview questions and asked in interviews as well. So that's why I have used this slide as well. So as I told you, we have this cable has two parts, which is DTE and DCE. This is known as data termination equipment. This is known as data communication equipment. You can just remember from the C, wherever DCE is involved, it means it is provide clocking. This is my clock, by the way. So it is providing clocking, and clocking is just, for example, the speed. Whereas DTE, which is the termination equipment, it is accepting those clockings. Examples like this is the router, or it could be the computer as well. On the other hand, the DCE, which will be in a service provider, this device will be installed in a service provider, while this DTE will be installed in our customer premises. So in our DTE, we know that router or the computer will be our termination points. On the DCE, modem or MUX, which is known as multiplexer. These things will be installed in the service provider. So this is their headache, how they are gonna pass our information to other service provider. But these are the things we need to keep in mind. So this is a cable, it's known as V.35 DTE DC cable, also known as a serial cable. So since we are here on the WAN, so these are the two most important protocols being used in a WAN: HDLC and the PPP. So just for the definition, it is high data link layer control protocol, works at layer 2, used to transmit synchronous data packet between point to point nodes. It is a Cisco proprietary, but this is the simplest of all protocol. This is by default. When you connect two Cisco devices or routers together, HDLC will be enabled by default. But what in case if you are using one Cisco device here, and let's say we have one Juniper router here, what are you gonna do? You cannot run HDLC over here. You must have to have the PPP protocol for the compatibility purpose. Okay, so from the definition it's written that point-to-point protocol is a data link. Also, it's a layer 2 data link protocol used to communicate between two routers directly. The benefit of this PPP has over HDLC, it can provide connection authentication, which means HDLC does not have any kind of authentication. It can do transmission encryption and data compression as well. So if I will do one-to-one comparison, you can see the HDLC is a standard HDLC for the Cisco, whereas this is standard protocol. It can be used with any devices, any vendors. There is no authentication. It uses authentication which is known as PAP or CHAP, password authentication protocols, and challenge handshake protocol basically. Then we have no protocol field here. It has a protocol field here. It doesn't support multiplexing. It's not only support multiplexing but the multi-link as well. Multi-link is just like the ether channel, logical bundling of physical devices as a one. Then it has no error detection. It can monitor and detect the errors. There is no any kind of quality, but it has the quality check with the help of LCP, which is link control. Okay, when we have the connection between two routers with the help of LCP, which is basically just like the heartbeat, it is gonna check the quality. So that's why PPP has so many advantages over HDLC. The only one advantage of HDLC is first of all, this is simple protocol to configure, and it is fast. Let's do a demo on HDLC and PPP very quickly on the same Cisco packet tracer as well. So I will close these things first, and from here do a file new. Okay, then click on this network devices, and I'm gonna use 2811 router for that. Drag and drop two routers. So from here select the cable, and I told you it is gonna use what kind of cable? Serial cable. It is not gonna use any kind of Ethernet cable, fast Ethernet or gigabit Ethernet or fiber optic. No. If you mouse over, it's written serial DCE or serial DTE. Okay, you can use either. If you select this one and you try to select, now you do not have any kind of option. If you try to do fast Ethernet 0/0, let's do it, the cable cannot be connected to that port because fast Ethernet has nothing to do with serial. So what is the solution? You have to add the module in this router. So click on that. First of all, switch it off, and you need to find this module first of all, which should be WIC 2T or WIC 1T. If you want, you can read the detail as well. So very quickly I will drag and drop here and power on this one. Similarly, I will go here, switch it off, drag and drop WIC 2T and switch it on. Now this time when you will select this cable and try to click this one, as you can see we have this serial. Click this one and click this one. I told you one will be a DCE, one will be a DTE. So as you can see here, it is providing clocking, so it means this is a DCE and this is a DTE, because this is a serial cable. For the IP, let's make it like 192.168.100.x network. So this will be 1 and this will be a 2, the host, the IP for this host. So let's very quickly click on this router and just drag and drop somewhere here so we can have a better look of these things. So click on CLI. As you can see, we have initial configuration dialog which we want to ignore just by typing no. Hit enter. We are on user mode. We need to go into enable mode and we need to take a look of interfaces. Show IP interface brief. As you can see, we have serial 030, which state is currently down and down. This thing is physical. It means if there is no cable attached, it will be down. And this has to do with the link or the protocol. Sorry, this has to do with the link, this has to do with the protocol. Means if the link is up, but what if the protocol is not running, like HDLC is not running, this will be a down. So if these both are down and down, it means not only the cable is down physically, but also the protocol is down. So we need to go into this interface and we will 0/3/0. Then we need to provide the IP first of all. IP, we said that we will give from the range 192.168.100.1 with the subnet mask 255.255.0. Sorry, and you have to mention IP address as well, ADDRESS, and just do no shut. Okay, so change state to down, and if I do show IP interface brief, it is still down and down because still it didn't get any kind of clocking or any kind of the heartbeat from other. So just save this one by putting WR. Come to this router and we're gonna do the same things but with a different IP. So click on CLI, no, enable, configure terminal mode, interface S0/3/0. This is I am getting from this thing. Okay, so we need to provide IP 192.168.100.2, then subnet mask is 255.255.255.0. Again I forgot address. Wow. And do no shut. As soon as I did no shut, as you can see, the links are up. Okay, now this time when I want to see the status, show IP interface brief, you can see both things are up and up. So at this time we should have a happy face because both are working, and from experience I can 100% sure this device can now ping this device. So let's try to ping 192.168.100.1, and as you can see the ping is successful. But we know this is a serial connection and we want to dig a little bit deep about the information. So what we can do, we can go further into detail of this link by providing command show interface serial 0/0/3/0 and hit enter. So it will give me a little bit more information. It will mention that what is the IP and the subnet mask I'm using, what is the bandwidth, the delay, which we will discuss a lot in detail when we will hit CCNA. Encapsulation, the most important part. We are using HDLC, which is Cisco proprietary, by the way. Okay, so that's it. It means the by default this is configured. As soon as I connect these two Cisco routers with the help of serial cable, I will get this HDLC. But what in case I want to change this encapsulation? This is very simple. You need to go again into the same interface by using conf t and then go into this interface by typing interface serial 0/3/0 and type in encapsulation and hit question mark. You will say currently we can, because we are by default having this one, then we have option configuring PPP as well and frame relay as well. Frame relay, by the way, has been obsolete and even no more is considered the part of CCNA as well. Okay, but still the teachers are teaching it just for the sake of information, because frame relay is the very simplest encapsulation, and with the help of frame relay we can further move to other technologies, which is like DMVPN. Okay, if you have gone through frame relay, DMVPN will be very simple for you to understand, and I digress here, sorry for that. So encapsulation, we're gonna use what? PPP, and hit enter. That's it. So did you notice something? As soon as I put encapsulation PPP, it means I am using PPP on this router. On the other router I am using HDLC, which is not gonna work. Why? Because these are total different languages. On one router we are saying you are going to communicate PPP. On another router we are saying you are going to communicate HDLC. If I take you to the configuration again, show IP interface brief, as I told you, the physical link is up, is happy, but the logical link or the protocol is down. So this is a very clear indication that physically we are connected, we have heartbeats going on, but we cannot speak the same language. So that is the reason this is down. So this is also one of the very good troubleshooting part as well. So Again, if I go into detail of this show interface, serial 0/3 says 0, and now you will see a little bit more as compared to HDLC. So encapsulation is PPP. It uses LCP, link control protocol, to communicate between each other, and it is closed right now. And it uses some other protocols as well, as you can see here: IPCP, CCP, CDP. It has to do with the Cisco Discovery Protocol, by the way, and we will discuss a lot in detail when we will hit CCNA. So this is just for the sake of information. As you can see, there are so many things going on. So it means PPP is much more advanced than HDLC. But you can see serial is up, but the line protocol is down or disabled. So what we need to do, and what is the solution for that? We know that this end is working fine. We have configured the PPP on that, but this is the problem. And how we can check? We can go into show interface for serial 0/3 size 0, and from here you can see it is still using HDLC, which we need to change. So very quickly we will go into that interface, configure terminal, interface serial 0/3 size 0, and we need to change encapsulation what? PPP. So before we change the encapsulation, I want to ping as well, 192.168.100.2. So as you can see, it is miserably failing. Control C to go back to this prompt, and go again, configure terminal, interface serial 0/3 size 0, and change the encapsulation PPP and hit enter. So as soon as I hit this enter, you can see the state is up. You want to verify show IP interface brief. Now you can clearly see this is up and this is up. So at this time of point, I think we clearly can ping the devices. So very quickly, just ping the other device, 192.168.100.2. As you can see, the ping is working fine. So for your HDLC and the PPP, this lab ends here. Let's move back to the slide.